All right, so my goal for us is that we get through the first 2 pages. We each do 2 problems. If we have time, although I don't like to rush word problems because I know they're intimidating, I would like to do the stuff on the last page, but we'll just see how it goes. So remember what I said earlier, we have the test Wednesday on this unit, so whatever we get through is what you're responsible for. So if we don't get to page 3, you're not responsible for page 3 for the test. Okay, so just keeping that in mind. So on page 1 and 2, we've got 2 different types of word problems. Probably the page 1 type you have seen before. It's a pretty standard algebra problem. The page 2, those are more fun, and we're going to have a good time when we get to them. So I'm going to start with example 1. I'm going to read it, and we're going to talk about it. And then you have an example that's super similar to that example. So example 1 says this. It doesn't even really make any sense. The painting, I should say the painting on, because I can't type, because it doesn't make sense to paint an easel. Anyway, the painting on the world's largest easel has a perimeter of 112 feet. Let's stop, because the key to word problems is determining what the keywords are, what they're telling you. What does the word perimeter, what does that mean? The distance all the way around something. How do you find the distance all the way around something? You just add it up. Okay, so this is an addition problem. Okay, so if you look at this and you were struggling on what to start, circle the word perimeter and just write yourself a little note. That perimeter means to add up all the sides. Okay, it's an addition problem. So that's the first type of word problem you're responsible for in this class are addition problems. You're going to be adding things up that are described for you. Might be perimeter, might be something else that you're given. So the painting on the world's largest easel has a perimeter of 112 feet. Its length is 8 feet more than its width. So we're given a relationship. Then the question is, what is the length? So here's the painting. There we go. That's the painting that's sitting on the world's largest easel right there. You're not really impressed with my artistic ability, but I don't blame you. It's okay. We are told that the perimeter of this is 112 feet. And you've already told me perimeter means to add up the sides. We're going to use that bit of information in just a moment. But what I want to do is I want to define my variables. I want to define my size. And when I can, I like to use a picture because that makes it easier for me to think. It says the length is 8 feet more than the width. So you can look at that statement. The length is 8 feet more than the width. So do I know what the width is? Well, what that tells me is when I figure it out, what do I do to the width to figure out the length? The length is 8 feet more than the width. So if it's more than, you're going to add. Okay, so if you have $8 more than me, then you would take my money and then you would add $8 to it. So more than means to add. Okay, so I don't know the width. We're all agreed on that? So what I'm going to do is I'm going to call the width, I'm pretty clever, I'm going to call it W. When you encounter a question, something that I need to clarify, please let me know. I know word problems are tough. I know we struggle with them. And I want this to be as clear as we can make it as we get some practice here. Okay, so this is my expression for the width. I don't know what the width is, but once I do know the width, what's the expression for the length? What am I going to call this? W plus 8 or 8 plus W. The order does not matter. So if you would have written 8 plus W, that is totally fine. Is everyone still tracking with me on where we've got those things right there? Now, I like to avoid formulas when I can. Some of you know the formula for the perimeter of a rectangle, and that's awesome. You can go ahead and use it. But you've told me that the word perimeter just means to add up all the sides. So that's what I'm going to do. I'm just going to add up all the sides. So I'm going to start on the left. The left side is W. And I'm going to rotate around clockwise. The top, W plus 8. The right is W. The bottom is W plus 8. And all of that is going to equal 112. Does anyone not see where I got this set up for the equation? Please speak freely. I just added up all the sides because that's what perimeter means. That's the key word. That's why when you read a word problem, it's super important. Identify anything that tells you a relationship. Perimeter, more than. Those are key words in this problem. All right, so here goes. Let's finish this up. The solving part's not the big deal here. W plus W is 2 plus 3 plus 4W. 8 plus 8 is 16. I'm going to subtract the 16 from both sides, and I get that, oops, I changed the variable. 4W is equal to, is that 96, I think? Then we'll divide both sides by 4, and I get W is 24. Last thing to do is always just answer the question. What is our question asking us here? The question says, what's the length? Okay, well, I know W is 24. What does W represent? The width. That's why I was clever and I picked W. And so now the length, we are told that the length, we're not told, we figured this out. The length is W plus 8. So in this case, that is 24 plus 8, or the length is 32 feet. Anyone confounded on where that conclusion came from? Any question at all about this first word problem? You've probably seen something super similar before. All right, do example 2. It's very similar, except instead of a rectangle, we're using a triangle. Give it your best shot. Just a little hint, if you're struggling, because the relationships on this one are a little more difficult than the previous one. This helps me think. I just drew a triangle. I labeled short, middle, long. It's going to help me establish what's going on where. So maybe doing that little thing will help you figure out the expression for the 3 sides. All right, I'm going to get started. Any questions you have are good questions, so please feel free to ask. I love questions, so we're going to be here till 10:15, whether you ask questions or not. The perimeter, again, it's a perimeter. Okay, the perimeter of a triangle is 2,400 feet. So the perimeter is 2,400 feet. Just like the last problem, that tells me the relationship. That tells me when I add up these sides, it's going to be 2,400 feet. So the biggest thing that I have to do is I have to figure out what the expression for each side is. So no easy task here. So the first one says the longest side is 200 feet less than twice the shortest. So we're given a relationship between the longest and the shortest side. Which one of them, according to the way it's written, am I going to call X? Which one do I not know that is going to, then I can get the other one from? Shortest, right? The shortest is going to be the X, or whatever letter you used, because I'm going to repeat this. It says, once you know the shortest, the longest side is 200 feet less than twice the shortest. Okay, the relationship is given in terms of the shortest side. Does that make a little bit of sense? No word problems are tough. Ask your questions if you got them. So let's write an expression for that. The longest side is 200 feet less than twice the shortest. So what's going to be my expression? What was that? Love it. This is twice. Twice means 2 times minus 200. Now, some of you have written this, and this is not right because subtraction is ordered, okay? The order matters. So if you wrote 200, because I understand the 200 comes first in the sentence, so I get why you would do that, minus 2x, that is not the appropriate relationship. The word less than means that you actually start with what comes after the word less than. Okay, so if you have $10 less than I have, then you would start with what I have and you would subtract 10 from that. Okay, so because of the word less than, this is the proper relationship. Okay, it's 200 less than 2x. The next sentence says the middle side is 200 feet less than the longest side. Okay, so here's the longest side, and I'm 200 feet less. So I'm going to take this right here, and what am I going to do with it to get the middle side? Subtract 200 more. So I've got 2x minus 200. That's the longest side, and then 200 less than that. Once you got those relationships, you then ask, what are the sides? So here goes. I'm just going to do what I did last time. I'm going to add up my 3 sides. I'm going to start over here on the shortest. I'm going to work my way around. So my shortest side is x. My middle side is 2x minus 200. And you can simplify this, but I'm just going to do one thing at a time. My longest side perimeter means adding up the sides. So here's my short, here's my middle, here's my longest. Now I just got to clean this up. The solving part, I don't expect the solving part on these to be the hardest part. Setting it up is definitely a challenge. I totally understand. So x and 2x is 3x plus 2 more, that's 5x. Minus 200 and minus 200 and minus 200. Your calculator is going to tell you that's minus 600. I'm going to get that 600 over to the other side, so I'm going to add it. So that gives me 5x is 3,000. And then when I divide, I get x is 600. This time the question said, tell me all the sides. So I will now do that. X is 600, so that tells me my shortest side is 600 feet. I'm sorry? No, go ahead, say it again. I think, yes, exactly. I wanted you to say it again because you were 100% right. You're going to plug it into each of these. So I plug the x in here, which is just x, is 600. And then I'm going to go down here because it's a little simpler. This is 2x, so 2 times 600 is 1,200 minus 200, that's 1,000. And then 2 times 600 is 1,200, minus 200 is 1,000, minus 200 is... And quick check. these three things, when you add it up, should add up to 2,400, which it does. So I did my arithmetic right. We're doing great. All right, so flip the page. This is an important page. There's one of these on the final exam. Okay, so you put a little asterisk. These are problems like the nursing department and the science department have asked us to do these because these actually pop up in real life. Okay, so being able to work with your percents and anything are important. So we're going to take our time. I'm going to do one, and then you're going to do one, which is going to be pretty much the same problem. These are called mixture problems. But before we do this, whether we're in intermediate algebra or whether we're in this class, I like to just be reminded on how percents work, because that's going to make our life pretty easy. So let's say after class you're pretty thirsty, and so you go to Publix and you're gonna buy a bottle of grape juice. Okay, the grape juice is awesome. Okay, so you're gonna buy a bottle of grape juice, and this is it's a 1 liter bottle, but just for arithmetic, we'll call it 1,000 milliliters. Same thing. But 1,000 milliliters just gives us something to multiply. But then you read the fine print as you're waiting to pay, and you say 1,000 milliliters, but it says that your grape juice is only 20% real juice. So you got 1,000 milliliters of liquid, but now you're told 20% of that is actually grapes. The rest is whatever else they put in those things. So if I'm interested in how much grape product I'm actually going to consume, what do I do with this percent to figure out how much real juice is in my grape juice? What do I do? Turn it into a decimal. 20% is what as a decimal? Okay, 0.2. And then what am I going to do with that decimal and my 1,000 milliliters? You're going to multiply, yeah, 100%. So what that means is if you let it settle or something, like up here, this is 20%. This is the part that's real juice. The rest of it's water and sugar and whatever else that they put in. Okay, but that's how my percent functions. Convert the percent to a decimal, and then you multiply that percent times a whole. Percents never stand alone. Percents are always a percent of something. You have to multiply it by something. So that's going to affect us, by the way, 200 milliliters. You want the answer? That's going to affect us as we go to do this mixture problems. This is example 3. Example 3 says how much pure alcohol should be added to 20 liters of 40%. So you're in chem class or you're a chemist, you got the mad white hair and everything, and you're got your evil lab coat on, and you want to have a 40 per, how much, no commentary necessary. How much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50%? Okay, so we want to boost the percentage for whatever experiment I'm about to do. Okay, I'm going to show you a way to set up this problem that is going to work no matter what the percents are or what the mixtures are. Okay, what I like to do is I like to draw I just like to draw a little box that represents each thing. So these two boxes represent what I'm adding together, and the box over here represents my result. And what we're going to do is we're going to go through, we're going to put the appropriate information in the appropriate place. So I'm going to read the problem again, and then I'm going to ask you a quick question. It says, how much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50%? Okay, fantastic. Let's start with what we know. Let's start with what we know. What do we have on hand? What do we know how much we have and how much percent is? What do we have? I'm sorry? Yes. So here's what I got. I've got 20 liters. And in this box, okay, if this box represents the 20 liters, what I'm told is 40% of that is alcohol. And so if you are familiar with chemistry, then the way alcohol or acid or any of the other things you're going to be asked to do this with, they're combined with water. So 40% of it is alcohol. The other 60% that I don't care about is just water. So just like my juice example. So this is my total. Okay, this is my percent. And so I want to know, what is my part here? So what am I going to do with these numbers to figure out how much actual alcohol is in this thing? What's that? Yes, I'm going to multiply 40%, which just like before, that's going to be 0.40 times 20. Let me read the beginning of this. You're going to help me with the box that we're adding. It says, how much? Does that indicate that I know or do I not know? I don't know. I'm looking for that. How much pure alcohol? Okay, so we're going to stop. So how much? So that means this box right here. What's the volume of it? Undefined. So what are we going to call it? Sure, I love X. Great. Okay. This is how much. I don't know how much it is. Now again, this method of writing things down works no matter what the percentage is. This says it's pure alcohol. So if something's pure, what's the percentage? How much of this box is alcohol if it's pure? 100. Yes. But if the problem said it was 80% alcohol, you would put 80%. If it said it was 5% alcohol, you put 5%. This works no matter what. Okay, well, what is 100% when I make it a decimal? It's 1.0. 100% of something is one whole unit. It's the thing. So this is 1.00 times X. Percent times the total amount. So I'm adding these two things together. This is my stuff I have on hand, the 40%, 20 liters of 40% solution. This is my pure alcohol. And now, what do I want it to equal? I want it to equal 50% solution. Now, here's the key question, last key question. The rest of this, solving it's not a big deal. What is my total amount that's going to be in this box? If I have 20 liters, okay, in a big pool right here, and then I start adding pure alcohol in it, what's going to be the expression for how much I have in this box? The same amount, meaning what? I started out with 20, but then I've added an unknown amount. So it's going to be 20 plus the X. That's my new amount. This is the 20 liters that I started out with. And then this is the amount of the pure alcohol that I poured in on top of it. 50% is 0.5, and then 20 plus X. Just for time's sake, because I want you to have enough time to sort through the problem I have for you, I'm going to take this one more step. We're just going to do the multiplying, and then the solving is not a big deal. You have calculators. It's like every other solving problem we've done. 0.4 times 20 is 8. 1 times X is X. 0.5 times 20 is 10. 0.5 times X is 0.5X. And then you're going to get your X's on one side, your numbers on the other. You're going to divide, and then you're going to end up with what the value of X should be. So what I would like you to do, we've got 8 minutes left in our class time. That's good. So we're just going to get through these first 2 pages. So when you're doing your homework, do your addition word problems, do your mixture word problems. You're not responsible for the other stuff. Okay, and I would like you to at least set up example 4 on that page. I'm going to leave this up here for a moment so you can look at and refer to. It's the same sort of thing. right, just for time's sake, we got 4 more minutes. So this is the same sort of situation. Okay, we want to strengthen a mixture from 10% to 30%. So how much pure alcohol should be added to 7 liters of the 10% mixture? So once again, let's start with what we know. So this is the box that I have on hand. I'm staring at. I've got 7 liters of this, and this is a 10% mixture. So we're going to do this problem in terms of the actual alcohol molecules here. So 10% is 0.10 times 7. This is the amount of alcohol, or whatever it is we're dealing with. So far, so good? These are difficult problems, so if you have a question, it's definitely warranted. Okay, again, we're doing pure alcohol, so I don't know how much, that was the question, but I do know that what I'm putting in is 100% alcohol molecules. So again, 100% is 1.00 times X. That's the amount of alcohol molecules. What's wrong? Well, I don't know how to respond, but we'll see. All right, continuing on the next, we want 30%. So what's my amount going to be up here? Sure. X plus 7 or 7 plus X. This is the amount I started with. This is how much I add to that. And I want this to be a 30% mixture. So I'm going to take this one more step. Again, you've done, if you got there, if you follow along, that's definitely the hardest part to the problem, is setting that up. The rest of this, 0.1 times 7, that's 0.7. 1 times X is just X. 0.3 times X. And then 0.3 times 7 is 2.1. And then you're going to get all your X's on one side, your numbers on the other, and you're going to divide. Okay, the rest of that is not too big of a deal. All right, so that is our time for the day.